Welcome to the Explainer. Today, we're literally turning dense algebraic expansions into your own personal cheat codes for conquering math. I mean, if you've ever looked at a massive algebraic equation and just felt this huge wave of dread wash over you, you are in the exact right place. Because we're completely reframing how we look at algebra today. Instead of seeing it as a series of tedious, manual calculations, we're going to look at it the exact same way a hacker looks at code. We're hunting for the exploits, the shortcuts, and the absolute fastest ways to get straight from a problem to a solution. Okay, let's dive right in by picturing this. You're staring down a pretty terrifying calculation, 104 cubed, and you have to do it without a calculator. Now, your first instinct might be to just put your head down and start doing the manual labor, right? Multiplying 104 by 104, taking that massive number, and then multiplying it by 104 all over again. It sounds like an absolute nightmare of carrying ones and aligning decimal places. But what if I told you there's a mathematical exploit that lets you bypass all of that heavy lifting? We're going to unlock a shortcut today that lets you solve this effortlessly, mostly in your head, by the end of this explainer. So, here's our roadmap for the explainer. We'll start with the power of math shortcuts, move on to mastering the square, tackle special fraction expansions, level up to cubes, and finally, unlock the ultimate math cheat codes. All right, part 1, the power of math shortcuts. Now, in the math world, these shortcuts are officially known as identities. But let's be real, the crucial point here is that an identity isn't just some random formula you have to memorize for a test. It's a universal truth. It works every single time, no matter what numbers you throw at it. Whether you substitute a 5, a -8, or literally 3 million into the variables, the left side of the equation is always going to equal the right side. It is a guaranteed ironclad shortcut. Think about expanding a plus b multiplied by a plus b. The long way forces you to multiply a by a, then a by b, then b by a, then b by b, and then you still have to combine the middle terms. I mean, why slog through all that tedious, step-by-step manual multiplication when you can just skip straight to the answer? By knowing the identity a squared plus 2ab plus b squared, you instantly bypass the busy work. It's basically mathematical teleportation. Moving right along to part 2, mastering the square. Think about how a simple squared bracket can build into a whole arsenal of related rules. We always start with our base identities, right? The standard expansions for a plus b squared and a minus b squared. But think about what happens when you take those first two equations and either add them together or subtract them from one another. You generate entirely new, incredibly powerful shortcuts. For example, if you just subtract the minus identity from the plus identity, all the squared terms completely vanish, and you're left with exactly 4ab. It's kind of like combining two basic hand tools to create a power drill. And if you're sitting there wondering, okay, but how does this actually apply to anything real? Consider a classic geometric puzzle. Imagine you need to find the area of a rectangle, but the only things you know are that its perimeter is 56 and its diagonal is 20. You literally don't know the length and you don't know the breadth. But watch this. The perimeter basically gives us length plus breadth, and the diagonal, if we use Pythagoras's, gives us length squared plus breadth squared. If we just plug those into our a plus b squared identity, that middle 2ab term perfectly represents twice the area of the rectangle. We completely solve the puzzle without ever actually knowing the individual side lengths. It's just pure mathematical elegance. Okay, let's jump to part 3, special fraction expansions. Now, I know this looks incredibly intimidating at first glance. Expanding x plus 1 over x squared really feels like it should result in this messy, overly complex fraction. But when you simply apply the square shortcut, the variables just beautifully cancel each other out right there in the middle step. The 2ab term becomes 2 times x times 1 over x. And since any number multiplied by its reciprocal is just 1, the x's vanish entirely. You're left with this surprisingly clean identity, x squared plus 1 over x squared plus 2. All that complexity just evaporates. This specific trick turns seemingly impossible problems into a total joke. Say you're given x plus 1 over x equals 2, and you're asked to find x squared plus 1 over x squared. Without our identity, you'd be agonizing over finding the actual value of x first. But with the identity, what seems like a complex fraction problem just collapses into basic arithmetic. You literally just square the 2 to get 4, move the plus 2 over to the other side by subtracting it, and boom, you have your answer, 2. Absolutely no heavy lifting required. All right, time to level up. Part 4. Cubes. So expanding cubes actually builds directly on what we've already done. When we look at the standard identity for a plus b cubed, we get a cubed plus b cubed plus 3a squared b plus 3ab squared. Pretty long, right? But if we factor out the common terms at the end, we get something way more useful. A cubed plus b cubed plus 3ab times the original bracket a plus b. Introducing this 3ab term is an absolute stroke of genius. It acts as the heavy lifter in these massive equations, and it allows us to factor and manipulate huge chunks of numbers with incredible speed. Okay, remember that impossible mental math question from the very beginning? 104 cubed? Well, here is where we completely hack it. By breaking 104 into a super simple addition, just 100 plus 4, we can now cube that entire bracket using our brand new tool. So it becomes 100 cubed plus 4 cubed plus 3 times 100 times 4, all multiplied by 104. 100 cubed? That's an easy million. 4 cubed is 64. And the rest is just basic multiplication with a bunch of zeros. You solve this massive, deeply intimidating problem quickly through simple addition and multiplication, totally bypassing the need for a calculator. Which brings us to our final section, Part 5, the ultimate math cheat codes. Reviewing the inventory of tools we've put together so far, you can clearly see this really satisfying mathematical symmetry as we move from the level 1 squares over to the boss level cubes. Notice the pattern here? Where squares have a 2 multiplying the terms, cubes have a 3. Where the signs flip for negative squares, they have a corresponding cascading flip for negative cubes. It is a beautifully organized system, and keeping these in your back pocket basically makes you an unstoppable force against algebraic expansion. But there's one tool that trumps them all. Okay, let's dive into the absolute masterstroke. This right here is the holy grail of algebraic shortcuts. The rule is this. If you have 3 numbers, a, b, and c, and you can prove that adding them together equals exactly 0, then something magical happens. The sum of all 3 of those numbers, each cubed, instantly shrinks down to just 3 times a times b times c. An enormous multi-step cubed equation literally collapses into a single, straightforward multiplication problem. Let's actually see this magic in action. Imagine having to calculate 8 cubed plus negative 5 cubed plus negative 3 cubed. A normal person without this toolkit would start doing the heavy lifting immediately. 8 times 8 times 8 is 512, then figure out negative 5 cubed, then negative 3 cubed, and then try to carefully add all those disparate positive and negative chunks together. It's super tedious and incredibly prone to error. But using our hacker mindset, you pause for a second and look at the base numbers, 8, negative 5, and negative 3. You realize that 8 minus 5 minus 3 is exactly 0. Bam! The condition is met. So the crazy part is that this massive block of scary arithmetic simply becomes 3 times our first number, times our second number, times our third number. It's just 3 times 8 times negative 5 times negative 3. The two negatives cancel into a positive. 3 times 8 is 24. 5 times 3 is 15. 24 times 15, instantly revealing the neat single number answer of 360. A problem that looks like a solid 10-minute headache is solved in literally 10 seconds. And really, that is the true power of identities. You aren't just memorizing static formulas. You're actively upgrading your mental software to recognize patterns that completely bypass the hard work. Armed with this new mindset, where math is all about finding the right cheat code rather than relying on brute force, what boss-level challenge are you going to hack next?